4.3, solve x squared plus bx plus c is equal to 0 by factoring. Okay, it doesn't necessarily have to be the equal to 0, but if it's equal to 0, that just means we need to actually solve it. Now, the problems we're doing will only have a 1 in front of x squared right now. Okay, 4.4 is where we add in a number other than 1 in front, okay, which requires more steps. So, the thing that I'm going to say again, it was probably said as a quote-unquote code word in your notes, was that there's never an excuse to get factoring wrong. Why?
Did you check it?
How? By what?
Foil.
Foil, okay? Always, always, always foil, okay? You should never get a factoring problem wrong. Because at a minimum, if you don't know what you did wrong and you can't figure it out, you foil, you tell me, I don't know what I did wrong, but I know my answer's not right, okay? Because at least I know you took the time to check it and realize that you're wrong, rather than just being so confident in a wrong answer, okay? All right. Obviously, we have some special types as well, but we'll get to those when we get to those in a minute. So, to start out with, number 4, we've got x squared minus 7x plus 10. Now, I know you factored before because you factor in Algebra 1, but I like to do, several problems to get a good refresh because people tend to forget how to factor. So, when we do this, okay, we are looking at factors of, in this case, 10, okay, that when we add or subtract them, they give us -7. So, I'm going to do this one, more detailed out, and then from there, we don't have to do all this. But, so factors of 10 that add up to give me -7 would be what?
2 and 5.
Yep, -2 and -5. Because when multiplied together, that gives me a +10. When added together, that gives me the -7. And so probably the way that you have traditionally had to write this, when you did it in Algebra 1, is you had to write x squared minus 2x minus 5x plus 10, and then you had to pull stuff out, factor by grouping, all that fun stuff, right? I'm assuming.
I don't remember that.
Okay, well, we don't do that in here. We just go, when it just has a 1 in front, x minus 2, x minus 5, and we're done. If you need to write the intermediate step, you can. I don't take off for that, obviously. Intermediate step we'll have to have in the next section because you have to factor by grouping to actually get it factored. But these ones we can just write this way. And we could FOIL to check x squared minus 2x minus 5x plus 10. And so that would give that to me. Factoring is usually easier the second time through. Usually when it hasn't clicked for people in Algebra 1, by the time I teach it and we're done, they're like, oh, I get it. So, r squared plus 15r plus 56. The other thing I'm going to tell you really fast is if there's ever a variable that you, let's say you just really don't like r's, okay, for some reason, or you don't like them in math problems and you'd rather them be x's, you can change them, I don't care, as long as you consistently change them throughout. Now, if there's multiple variables in a problem, obviously you can't really do that. But if you're like, no, I really don't like r's and I want to use x's, that's fine, but I'm going to use what the book is using. So I need factors of 56 that when I add them together give me a positive 15.
8 and 7.
8 and 7. So this is going to be r plus 8 and r plus 7. Eight q squared minus 11q plus 28. So I need factors of 28 that when I add them together, I get negative 11.
-7 and -4.
-7 and -4. So q minus 7 and q minus 4. And it doesn't matter which one you write first. If you did 4 first and then 7 first, or 7 second, that's fine too. It's going to give you the same answer either way.
Why?
I don't know how to do it.
Today would be an easy state of
Did
race.
you just say we're not gonna race?
This is like the easiest
Because
thing.
you don't know how to do it?
I know how to do it, but I don't know. Like, I'm not quick.
That's not even
This is
fair.
like-
I'm not quick with that.
That's
I'm literally not quick with that.
not-
I would literally have to give you all the options.
I'm literally
28,
can't
3
race
and
for
8. You
literally
have score 7, 3 and 8.
You
You have
can't
like
just
multiple
opt out.
options.
You can't just opt out because you don't know how to do
Yes,
it.
we.
I think he's just taking a forfeit, Tristan. I think you just get the dub on this
no,
one.
No,
Yeah.
no, 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 Remember that one day you were like, I gotta learn this.
That was
That was
on
when we were doing
the
a
review.
review.
That wasn't like
That
a
counts.
section.
That counts.
That was
No, it
something
does.
hard.
Yes, it does.
Like this.
That was a review.
Maya's like, this isn't
This
hard.
isn't a review. This is like
Yes, it is. It literally is a review.
All right.
This is so easy, Christian.
Up to this point, every problem has had a positive value over here, which means that both factors either have to be positive or both factors have to be negative. Okay. Now we have one that is negative, which means that when I multiply two things together, I need something that's positive and something that's negative, okay, to give me the middle term. The middle term is a negative in this case, so that means that my negative number needs to be the bigger number, and my positive number needs to be the smaller number. So I need factors of negative 12, so I need one negative, one positive, that when I combine them give me negative 4.
Negative 6, positive 2.
Negative 6 and positive 2. So x minus 6 and x plus 2.
Like Christian, literally.
what if you did x plus 6 and x minus 2? Does that matter?
Yes. Because if I did x plus 6 and x minus 2, when I refoil it, I get x squared plus 6x minus 2x minus 12, and that's going to give me a positive 4x in the middle, which doesn't match.
Okay.
So yes, it does make a difference. All right, 12. C squared minus 9c minus 18. So I've got a negative again, so I need factors of negative 18. So that means I need one positive, one negative that combined give me negative 9.
6 and 3.
Negative 6.
Actually, no, that's more like
Well, negative 6 and negative 3 combined give me positive 18, and it's supposed to be negative, so that's not going to work. So I'm going to take this moment to refresh your mind on how to do a factor tree. So factors of 18, 3 and 6, okay, because those are the two that we've been throwing around. 6 are 3 and 2. And so I can use any combination of these to try to get that. Obviously 18 and 1. A lot of people forget that factor is an option. It obviously doesn't work for this one, but it sometimes does work, especially with like 5 and 1 or something like that when you need a combo of 6. That will work. But I could do 3 and 3, which is 9 times 2. That would be 18, but combined that gives me negative 7 if I use the right things. So that doesn't work. We've obviously already tried 6 and 3, and we said that didn't work. 1 and 18 doesn't work. So in this case, nothing actually works. Okay, and this one is what we call not factorable. Okay, because there's no factors that when I combine them give me the numbers that I need. Okay, 6 and 3 obviously multiply and give me, or I can multiply negative 6 and positive 3 and get negative 18, but when I combine them, I don't get negative 9.
Couldn't you like 6 times 2 is 12 minus 3
You're confusing Christian even
What?
more.
What?
What is that?
Well, 12 times 3 is an 18, so no.
Okay.
It has to be these numbers at the bottom.
Okay.
Those numbers would have to be what are being used, or like 18 and 1. Now, if it's easier for you, so like Christian, I don't know if you've done this before or not. I'm assuming you did in Algebra 1, but you could literally list out the factors like this.
Yeah.
You can do that, and that's another option, but I'm trying to remember what class it was. It was Algebra 1B, like my first year teaching, I think, and we were doing factoring, and there was some number that they could not for the life of them figure out how to factor. They tried every option except for, they were trying to list all the factors, but it was a number that was like 327 or something. Like it was some giant number and they could not figure out what it was. A factor tree would have been better for them, and they tried every factor except for the one that it ended up being. So it might be easier to do this, but sometimes it's easier to do a factor tree and try it. So don't just write a giant X in the box so when you take a quiz or a test, tell me that it's not factorable, okay? Just have to pick on you a little bit. All right, so those are the like generic ones. Let me do one more actually, just because it's a different one than we've had. M squared plus 8m minus 65. Okay, so now I had ones that I had, both were positive in number 6. I had a positive and a negative in number 8. I had both negative in number 10, but now I have a negative here and a positive here. So that means when multiplied, I need one negative, one positive. The positive one is going to be the bigger number. Okay, so factors of 65, which probably are not things that you know off the top of your head. 5 and 13, okay, you do know it off the top of your head. So 13 has to be the positive one because 8 is positive, okay, so it's going to be m plus 13 and m minus 5. And the whole thing of not getting factoring wrong by foiling is because when you foil, if you did the wrong signs, like we did up here with number 10, that would show you that the signs didn't match. So that's why we do that. If you had done, the signs backwards. But anyways. All right, so that's the like regular, you really have to think about them problems. The next ones are to factor the expression, and these are all special types. Okay, so these are either a difference of squares or a perfect square trinomial. Based on what they give you. If there are only two numbers or two pieces given, it is a difference of squares. If there are 3, it's a perfect square trinomial. Tri means 3. That's how you know the difference in the two. Sometimes I will tell you, I let you tell me what special type it is for extra credit on a quiz or a test. So make sure you know how to tell the difference. 16, we've got b squared minus 81. So what squared is 81? 9. So what this is a difference of squares. Tells us that as long as both of these pieces are perfect squares, then it's just b plus 9 and b minus 9. These are my favorite ones. These are the least amount of work.
That's a little itchy there.
All right, so that was a difference of squares. This one, 18t squared minus 16t plus 64. So this is a perfect square trinomial. There are 3 pieces. Okay, now if you didn't recognize that it was a perfect square trinomial, you could still factor this the normal way. Okay, like we did up here. Absolutely will work. It's just going to be a factor that's repeated. Okay, so the factors, the form for a perfect square trinomial, just as a refresher, is a squared plus 2ab plus b squared. So t squared is my a squared in this sense, okay, and then it's 2 times t, and then b squared is 64, so what squared is 64? 8, and then whatever sign is on the middle term is the sign that we use, okay, so this is going to be t minus 8 squared. Okay, so if you were going to FOIL this back, it would be t minus 8 times t minus 8, and then you FOIL it, and then that will give you this here. Now, if you had not recognized it was a perfect square trinomial, you would have gotten, you would have been like, okay, factors of 64 that give me negative 16 would be negative 8 and negative 8. And then you would have had t minus 8 and t minus 8. Just make sure you combine them when it's a repeated factor like that, if you don't recognize the perfect square trinomial. Let's see, 20 c squared plus 28c plus 196. So
Oh,
this kind of looks like a perfect square, right? But it probably not. Oh, it might be one you know off the top of your head, but it's not a common one. Huh? Did you say 14?
Yeah.
Yep, 14 is the perfect square. So this is going to be, this is a plus sign here. So this is going to be c plus 14 squared. All right, solve the equation. So now what solve the equation means is these are now set equal to 0. So once we factor, we set each factor equal to 0 and solve for the variable. Okay, so we'll have either one or two answers depending on what type of factoring it was. So 24, I've got x squared minus 8x plus 12 equals 0. So factors of 12 that give me negative 8 are
-4 and 2.
Negative 6.
negative 4 and 2 would be 8 multiplied together.
Negative 6.
Yeah, she said 4 and
Yeah.
2, which didn't work. X minus 6 and x minus 2. Because when I multiply those, it gives me a positive 12. Add them, gives me a negative 8. So that's equal to 0. So now we take each piece and set it equal to 0. So x minus 6 equals 0 and x minus 2 equals 0. So x equals 6, x equals 2. And those are my answers to that.
No.
28 b squared minus 6b plus 9 equals 0. Now, what is this?
3 times 3. Oh.
Negative
Which
3.
is a,
Square.
what type is this? It's a special type.
I don't know what it's called.
It's perfect square trinomial, okay, because this is something squared. So, b minus 3 squared equals 0. So you only need to do it once because it's just that term repeated. So that's just going to be b minus 3 equals 0 or b equals 3. Okay, now what you will learn when you get to pre-cal, so I'm going to give you a little bonus information here, is that this factor or this 0 has a multiplicity of 2, just meaning that it occurred twice. That's all that tells you. All right, one more and we will be done. 36 m squared equals 7m.
That's cheating.
Not producible. Actual. X.
It is though.
X.
Liar.
I need to get it, huh?
7 and 1.
Negative 7.
I need to move all the pieces to one side because I've got to have it equal to 0. So I'm going to have m squared minus 7m equals 0. Now, what do both of these have in them?
M.
1.
So I'm going to,
Oh.
well, yes. So I'm going to take out an m, which leaves me with m minus 7. Okay, and this is an acceptable way to factor. Sometimes factoring involves just pulling something out of it. So now I can do the same thing. I'm going to have m equals 0. That one's easy. I have no work to do. M minus 7 equals 0. So m equals 7. So my answers would be m equals 0 and m equals 7.
I'm literally gonna win on this one.
Wait, I don't want to lose one.
I'm ready.
Literally no competition.
I'm
All right.
really ready.
Oh!
Your problems are 3 through 35, every other odd. Okay, now, in case you haven't seen that, that would be 3, skip 5, 7, skip 9, 11, and so on and so forth. Okay? So it means you take every other odd and you solve it.